First, we'll recall certain concepts of logarithms. If a power b is equal to c, then we define log c to base a is equal to b. This is the definition of logarithm. If a power b is equal to c, then log c to base a is equal to b. See, logarithms will exist. Suppose you are having log f of x to base g of x is there. This will exist when f of x is greater than 0, g of x is greater than 0, g of x not equal to 1. So log f of x to base g of x existence will be there under these circumstances. So whenever you get a log function like this, you have to take care of all these points. Right? So the next point is log mn to be any base is equal to log m to base a log n to base a. Log of m by n to any base log m to base a minus log n to base a. Log of m power n to base a is equal to n log n to base a. Right. Recall all these things. The next point is, suppose you are having log f of x to base g of x is equal to, let us say, h of x. Then f of x is equal to g of x whole to the power of h of x. So this is no problem. So when you come across inequality, log f of x to base g of x is, let us say, less than h of x. Here you should be careful. If you want to remove log like this here, you have to watch the base. If g of x lies between 0 to 1. So if base is a proper fraction, then send g of x to this side. Implies f of x is greater than g of x whole power h of x. So if base is a proper fraction, if you remove log, send g of x to this side means you have to reverse the inequality. If g of x greater than 1 implies f of x is less than g of x to the power of h of x. So g of x greater than 1 means the inequality remains the same. So this is a very important point to notice. Log of f of x to base g of x, let us say, less than log h of x to base g of x. So base is same. Then if 0 less than g of x less than 1, then f of x is greater than h of x. If base is a proper fraction, then if you remove log on both sides, inequality should be reversed. If g of x is greater than 1, then f of x is less than h of x. F of x is less than h of x. So inequality inequalities, you should be very careful like this. Right? It's very easy to follow. You should remember all these points. So as far as logarithms is concerned, these are very important points. Next, I think change of base rule. Okay, go off right on that better. Log a to base b is equal to log a to base x by log b to base x. Right? Which is called change of base rule, of course. To any base you can write. Next, 1 by log a to base b is equal to log b to base a. Right? But according to that. The next point is, you also remember this, log a to base b, log b to base a is log a to base c. Right? Next. F of x to the power of log of g of x to base f of x is equal to g of x. So if this base and this are one and the same, then you can write directly what g of x. F of x to the power of log g of x to base f of x is equal to g of x. See, this can be easily proved. You take log on both sides, you will get LHS is equal to RHS. So these are the main points as far as logarithms are concerned. Now we will practice a few questions based on these concepts. Four to the power of log 3 to base 2 plus 9 to the power of log 4 to base 2. 4 to the power of log 3 to base 2, log 3 to base 2, 9 to the power of log 4 to base 2 is equal to 10 to the power of log 83 to base x. Then find the value of x. So you can write like this. This is 2 square. So 2 log 3 to base 2. This is 9 to the power of, this can be written as log 2 square to base 2 is equal to 10 to the power of, like this. See, this 2 can be kept here. This will become what? 9. Fx to the power of log g of x to the base f of x is what? 9. Plus this is 9. So this is, you can bring 2 to here, then log 2 to base 2 is what? 1. 9 square is what? 9 square happens to be 81. 9 square happens to be 81 you will get. Is equal to, see, this is 2 square. So you are going to get 2 to the power of 2 log, right? 3 square. Right. Okay, no problem. Right. 10 to the power of log 83 to base x. As per the problem, I'm doing it. This is 2 square. This is 4 to the power of log 3 to base 2. So 2 square I can write. Log 9 to base 2. This is 9. Okay. is given. You see. Or half. You may open it in 9, right? Because you use 9 here, right? This is 4 to the power of, you can write like this, log 3 to 3 square you can put. Then this 1 by 2 can be taken outside because the result is what? Log a power m to base b power n is m by n log a to base b. So this will become 4 power 1 by 2. 4 power 1 by 2 is what? 2. So 83 is equal to 10 power log 83 to base x. Okay, please change the problem. Then you will get log 83 to base 10 is equal to log 83 to base x. X is equal to 10. You can do like this. Right? So the next question is log x minus 1 to base 0.3 less than log x minus 1 to base 0.09. Solve for x. Log x minus 1 to base 0.3 less than log x minus 1 to base 0.03. See, first of all, log should exist, means x minus 1 greater than 0. So x is what? Greater than 1. So this is log x minus 1 to base 0.3 less than. See, this can be written as 0.3 whole square. So log x minus 1 to base 0.3 whole square. These two can be brought here. You bring everything onto one side. Log x minus 1 to base 0.3. 1 minus 1 by 2 is what? 1 by 2. Like this. Okay? 1 minus 1 by 2. Like this. 1 by 2 you can cancel. So you are having log x minus 1 to base 0.3 less than 0. So if you remove log, the base is a fraction. Therefore, the inequality will reverse. So x minus 1 greater than 0.3 whole power 0. So x minus 1 greater than 1, x is greater than 2. Already your x happens to be what? Greater than 1. So what is the intersection of these two? X is greater than 2. Your final answer is x belongs to 2 to infinity. X belongs to 2 to infinity. Yes, I think you are fine. First, write domain. Then you just change this 0.9 as 0.3 whole square. 2 can be brought here and you will get like this. Half you can cancel. Then you will get like this. When you remove log, inequality has to be reversed because the base happens to be a proper fraction. If base is more than 1, you have to keep the inequality as it is. Right? The next question is log to base 7. Log of root x plus 5 plus root x to base 5 is equal to 0. Solve for x. See, first this log. If I remove this log, you will get 7 power 0 is how much? 1. Before that, write the domain. Root x plus 5 plus root x must be greater than 0. And x plus 5 must be greater than 0. x must be greater than 0. X plus 5 must be greater than equal to 0. X must be greater than equal to 0. You will get x greater than equal to minus 5, x greater than 0, intersection is what? X greater than equal to 0. Under these circumstances, anyhow, this is positive only. Watch, root 5 plus 0 is definitely what? Positive. Now first remove this log, you will get log of root x plus 5 plus root x to base 5 is equal to 1. Remove this log. Root x plus 5 plus root x is equal to 5. Root x plus 5 plus root x is equal to 5 you get. Now square on both sides. X plus 5 plus root x plus 2 root x into root x plus 5 is equal to 25. Root x plus 5 plus x, sorry. We will get like this. So finally what we will get? 2 into root of x into x plus 5 is equal to how much? 25, 20 minus 2x. So you cancel 2 throughout, you will get what? 10 minus x square inch. X square plus 5x is equal to 100 plus x square minus 20x. X square will bring it to this side. 25x is equal to 100, x is equal to 4. X is equal to 4. See, x is equal to 4, is it satisfying this domain? Yes. So x is equal to 4 is a solution. Yes, understood? If you want to put x is equal to 4, you will get this is 3, this is 2, 5. Log 5 to base 5 is what? 1. Log 1 to base 7 is 0. So you can verify like that. A greater than 0, B greater than 0. A to the power of log B to base A whole power x. A to the power of log B to base A whole power x is equal to B to the power of log A to base B whole power x. Find the value of x. Find the value of x. This is our next question. A greater than 0, B greater than 0. A to the power of log B to base A whole power x is equal to B to the power of log A to base B whole power x. Then show that x is equal to 1 by 2. This is a standard problem, of course. Now take this log A to the power of log B to base A whole power x. B to the power of log A to base B whole power x. Take log on both sides. Take log with respect to B on both sides. With respect to base B. With respect to base B. Then you will get log of A to the power of log B to base A whole power x to base B is equal to log of B to the power of log A to base x to the base B. So this can be brought to here. So log B to base A whole power x into log A to base B is equal to log A to base B whole power x into log B to base B. Log B to base B is how much for you, 1? Right? So finally you are going to get log B to base A whole power x. Right? You send this to here. You will get log a to base b whole power x by log a to base b. So log b to base a whole power x, log a to base b whole power x. So log a to base b whole power x is equal to what? Log a to base b whole to the power of x minus 1. See, log b to base a is as good as what? 1 by log a to base b. So this is as good as log a to base b whole power minus x, right? Log b to base a is 1 by log a to base b. 1 by log a to base b is what? Log a to base b whole power minus 1. So minus x. So log a to base b whole power x minus 1. So minus x is equal to x minus 1. X is equal to 1 by 2. Yes, understood? So this is a very important result. A to the power of log b to base a whole power x is equal to b to the power of log a to base b whole power x implies x is equal to 1 by 2 can be proved like this. Take log with respect to b on both sides. Take log with respect to b on both sides. Then bring it to here, log a to base b, send log a to base b to that side. You will get like this. Here, this is, recall, log b to base a is equal to 1 by log a to base b, right? So therefore, you will get your answer like this. Yes, I hope you are following the problem. You read also, sir? Alpha comma beta are roots of the equation x square minus x into 3 plus 2 to the power of square root of log 3 to base 2 minus 3 to the power of square root of log 2 to base 3 minus 2 into 3 to the power of log 2 to base 3 minus 2 to the power of log 3 to base 2 is equal to 0. The value of alpha square plus beta square plus alpha beta. Find the value of this is our next question. See, just now I proved one result. A power log b to base a whole power x is equal to b power log a to base b whole power x implies x is equal to 1 by 2. Right. So based on this result, you observe these two. So A is what 2, B is what 3. So these two are what equal, right? So this is 0. 3 power log 2 to base 3 is what 2. 2 power log 3 to base 2 is what 3. So therefore what happens to the quadratic? X square minus 3x, because this is 0, minus 2 into this is what 2 minus 3 is equal to 0, which is as good as x square minus 3x plus 2 is equal to 0. If you solve this, alpha is 1, beta is equal to 2. You substitute 1 plus 4 plus 2, which is 7. So this is the importance of this result, I think you have seen. So this is a very important result. The next question is alpha comma beta are roots of ax square plus bx plus c is equal to 0. alpha and beta are roots of this equation. A is equal to 1 plus, A is equal to not 1 plus 2 to the power of log 3 to base 2 minus 3 to the power of log 2 to base 3. B is equal to 1 plus 2 power square root of log 3 to base 2 minus 3 power square root of log 2 to base 3. C is equal to log of to base 2 log of to base 2 square root of 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 1, 2, 3, 4, 5, 6. Like this, 6 square roots. C is equal to this. HM of alpha comma beta. HM of alpha comma beta you have to calculate. Say alpha and beta are what? Roots of that equation. A, B, C are given by this. You have to calculate harmonic mean of alpha and beta. Straight away your A will be what? 2 power log 3 to base 2 is 3. 3 power log 2 to base 3 is what? This. Therefore A is 1. This is how much? Just now I was saying this is 0, right? This is also 1. Now this is 2 power 1 by 2 whole power 1 by 2 6 times. Means this is all how much? 2 to the power of 1 by 2 power. See 1 by 2, 1 by 2, 1 by 2, 1 by 2 6 times. So 2 power 1 by 2 whole to the power of 1 by 2 whole to the power of 1 by 2 whole to the power of 1 by 2 6 times means 2 to the power of 1 by 2 power 6. So this is nothing but log to base 2 log to base 2 2 to the power of 2 to the power of 1 by 2 power 6. So 1 by 2 power 6 will come here. 1 by 2 power 6. This is nothing but 2 power minus 6. So finally what? Minus 6. I think I am following this. 2 power 1 by 2 power 6. 1 by 2 power 6 will come here. Log 2 to base 2 is 1. 1 by 2 power 6 is 2 power minus 6. So I will get minus 6. So that is our C. So the equation is what? X square plus x minus 6 is equal to 0. So alpha is equal to minus 3. Alpha is equal to minus 3. Beta is equal to 2. Correct? What is HM of alpha beta? 2 alpha beta by alpha plus beta. Harmonic mean, definition of harmonic mean of A and B is what? 2AB by A plus B. Harmonic mean of alpha and beta is 2 alpha beta by alpha plus beta. Alpha you know, beta you know, you substitute, get to the answer. The next question is, solve the equation 2 log of to base 2 log x to base 2 plus log of to base 1 by 2 of log of to base 2 root 2x is equal to 1. Is equal to 1. Solve the following equation. So to do this, I will call log x to base 2 is equal to t. then you should remember that your t value should be greater than 0. Then only log t will exist. See, if I call this as t, this becomes log t to base 2. So you should remember that t must be positive. Then what happens to this? Log t to base 2 plus, see, I can write this as what? 2 power minus 1. Minus 1 I can take outside. Therefore minus, this is log 2 of, this is what? Log of 2 root 2 to base 2 plus log x to base 2 is equal to this. Understood? Log m plus log n form. Log x to base 2 is what? T. So this is 2 power 3 by 2. So this is all how much? Finally you will get 3 by 2. Correct? So this is finally what? Log t square to base 2 minus log of 3 plus 2t by 2 to base 2 is equal to 1. It's just like log n minus log n. So log of to base 2 t square by 3 plus 2t by 2 is 1. So remove log, send 2 to that side. 2t square by 3 plus 2t is equal to 2. Now solve this quadratic, you can cancel 2 of course. T square minus 2t minus 3 is equal to 0. So t is equal to 3 or t is equal to minus 1. T is equal to minus 1 ruled out because t should be positive. So log x to base 2 is equal to 3, x is equal to 8. So you can solve the equation like this. Yes, understood? 0.5 whole to the power of log of to base 3 log of to base 1 by 5 of x square minus 4 by 5 greater than 1 find possible values of x. Find all possible values of x. See, first of all, listen, we will see the domain later. First we will listen this concept. A power x is greater than 1. A power x is, let us say, greater than 1. See, if a value lies between 0 to 1, then x must be less than 0. Then only it is possible. I'll give you an example. Consider 1 by 2 whole power x greater than 1. See, if x is a negative quantity, then what happens? 1 by 2 whole power minus 1 means 2 you will get greater than 1. It's very simple common sense. If a greater than 1 implies x is what? Greater than 0. So this is the first concept you should notice. You might have studied this in your lower classes, right? So, 0.5 is how much for you? Fraction. So therefore, what is your first step? Log of to base 3, log of 1 by 5 of x square minus 4 by 5 is what? Less than 0. Because base is a fraction. Understood? Now, you should remove this log. The base is what? More than 1. So if you remove this log, 3 power 0 will get inequality remains same. So you will get log 1 by 5 of x square minus 4 by 5 less than 1. Right? 3 power 0 is 1. Since 3 is more than 1, if you remove log, inequality remains same. Right, here. Here 1 by 5 is a proper fraction. So therefore what happens? If you remove log, inequality will reverse. X square minus 4 by 5 greater than 1 by 5. So you will get x square greater than what? 1. X square is greater than 1 will get. X square is greater than 1. Therefore, x is less than minus 1. Or x is what? Greater than 1. Solve that inequality. So this is actually what? X square minus 1 greater than 0 will get. If we solve, we will get like this. But remember, x square minus 4 by 5 must be greater than 0. Then only log will exist. Isn't it? Then only logarithm will exist. So therefore, what you will get? X is less than minus 2 by root 5. Or x is greater than 2 by root 5 will get. Now, you have to take intersection of these two. Minus 2 by root 5. Is it less than minus 1 or greater than minus 1? Minus 2 by root, see root 5 is 2 point something. So this is a fraction. So therefore this is definitely greater than minus 1. This is what? This is less than 1. So intersection of these two is what? X belongs to minus infinity to minus 1 union x greater than 2 by root 5, x greater than 1 means what? 1 to infinity. Intersection is that only. You should consider intersection of these two. Yes, understood? So finally this is the intersection. Yes, I hope you are following these concepts. Just watch. The next question is 5 into log x to base 2 plus log y to base 2 is equal to 26. xy is equal to 64. Find mod x minus y. Find mod of x minus y. This is our next question. 5 into log x to base 2 plus log y to base 2 is equal to 26. xy is equal to 64. What is mod xy? You call log x to base 2 as alpha. Log y to base 2 as beta. Then you will get log x to base 2 alpha, log y to base 2 is what? Beta you can call. Okay. So you are going to get 5 into alpha plus beta is equal to 26. So alpha plus beta is equal to what? 26 by 5. See, what is 5 into this, okay? Log x to alpha plus beta, right? See, xy is equal to what? X is 2 power alpha. Y is what? Just what? I think there is something wrong with the problem. See, the problem is over, sorry. This is log x to base y, log y to base x. Sorry. Please correct the problem. See, 5 into log x to base y plus log y to base x is 26, xy is 64. What is mod x minus 1? Okay. You can call log x as alpha, log y as beta. This is 5 into See, log x to base y is what? Log x by log y. So alpha by beta. This is log y by log x. Beta by alpha is 26. So alpha by beta, beta by alpha is equal to 26 by 5. If you solve this, you put alpha by beta t, you will get t plus 1 by t is equal to 26 by 5. Solve this quadratic, you get t is equal to 5 or t is equal to 1 by 5. Right? So t is equal to 5 you consider. Then alpha is equal to 5 beta you will get. Okay, understood? Now, listen. Log xy is there. So what is alpha plus beta? Log x plus log y is what? 64. So alpha plus beta is equal to, alpha plus beta is equal to log xy. Alpha plus beta is equal to log xy you got. Log xy is equal to how much? 64. Correct, log xy is equal to log 64. Right, no problem. Yes, understood? Now listen, alpha is what? 5 beta. So 6 beta is equal to log of, you can write it as what? 2 to the power of 6. So 6 beta is equal to 6 log 2 you will get. 6 will cancel. So you will get beta is equal to log 2. Alpha is equal to what? 5 log 2. Alpha is equal to 5 log 2, you got it. So now, look like this. Log x is equal to alpha. Alpha means what? 5 log 2. Which is log of 2 power 5, which is log 32. So log x is log 32 means x is what? 32. What is beta? Log y is equal to log 2. So y is equal to what? 2. X is 32, y is 2. Substitute x and y values. You will get your answer. Yes, I think you are following this. See what I did? Log x alpha, log y beta. 5 into log x by log y, alpha by beta, beta by alpha, you got like this. You call alpha by beta is equal to t, then you will get t plus 1 by t, 26 by 5, t value is equal to 5, t value 1 by 5. Then, since t value is 5, alpha by beta I will take 5, alpha is 5 beta, I can take this also, makes no difference. You will get reverse here. Next is xy. So who will get xy? Consider alpha plus beta. Then log x plus log y is what? Log xy. Log xy is log 64. The alpha is what? 5 beta. So 6 beta is log 2 power 6. So beta is equal to log 2 you got. Alpha is 5 log 2 you got. Then come back to this. Log x is equal to alpha means 5 log 2. Log x is log 2 power 5 log 32. So x is 32. Log y is beta log 2. So y is equal to 2. So x is 32, y is equal to 2. Therefore, your mod x minus y is equal to how much? 30. This is how you have to do this. So the next question is, solve mod x minus 1 to the power of log x square to base 2 minus 2 log 4 to base x. 2 log 4 to base x is equal to x minus 1 whole power 7. X minus 1 whole power 7. So this is our next question. So listen. The base of LHS is positive. So positive quantity to the power of anything is always positive. Therefore, this also must be positive. You should always see that x minus 1 greater than 0. So here x minus 1 cannot be less than 0. If this is less than 0, whole power odd number is what? Negative. So that's the first point you have to notice. Anyhow, x must be positive, x greater than 0, x not equal to 1 also. Why? Because logarithmic base happens to be x. Now listen, whenever you are having, let us say like this, a power, okay, so here x minus 1, here also x minus 1. If x minus 1 is equal to 1, 1 power anything is 1, 1 power 7 is also 1. So x is equal to 2 is a root, because x is equal to 2 satisfies this, satisfies this, satisfies this. So x is equal to 2 is first one solution. Let x minus 1 is not equal to 1, mod x minus 1, or x minus 1 not equal to 1. So when x minus 1 not equal to 1, this must be equivalent to what? 7. So you will get log x square to base 2 minus 2 log 4 to base x is equal to 7. You can bring 2 to here. I will write once again. Right. 2 log x to base 2, 2 log 2 square to base x is 7. You can call log x to base 2 as t. Then 2t, this minus 4 into, when log x to base 2 is t, log 2 to base x is what? 1 by t is 7. Okay. So 2t square minus 7t minus 4 is 0. So 2 4 is 8. So 2t square minus 8t plus t minus 4 is 0. So 2t into t minus 4 plus 1 into t minus 4 is 0. T is 4. T is equal to minus 1 by 2. T is equal to minus 1 by 2. So now log x to base 2 is equal to 4 means x is 16. No problem. You can have, because 16 will satisfy all those things. Log x to base 2 is equal to minus 1 by 2. So x is equal to what? 2 power minus 1 by 2, which is 1 by root 2. Okay, no problem. X value should be greater than 1, so it cannot be. Listen, here x value should be greater than 1. So therefore, you cannot have 2 power 1 by minus 1 by 2. This is 1 by root 2 you will get. So your only answer is what? 16 and 2. So 2 is a solution, 16 is a solution, 2 power minus 1 by 2 cannot be a solution because x minus 1 has to be greater than 0. Yes, understood? This is how you have to think on this question. Right, understood? I think you have found how to take care of all the constraints in the problem. Log of x plus 1 by x to base 0.2 to base 0.2 greater than or equal to 1. Greater than or equal to 1. This is our next question. See, first of all, x plus 1 by x must be positive. right? So you can draw the wavy curve. So 0 and here what? Minus 1. When x is greater than 0, all are positive, we will have like this. So x belongs to minus infinity to minus 1, union 0 to infinity. This is the domain of the inequation. Since logarithmic base is a fraction, if I remove log, inequality will reverse. So x plus 1 by x less than or equal to 0.2. 0.2 means what? 2 by 10 means 1 by 5. So you will get x plus 1 by x less than or equal to 1 by 5. When you get like this, I told you should not blindly cross multiply, to bring everything onto one side. X plus 1 by x minus 1 by 5 less than or equal to 0. So 5x plus 5 minus x by 5x, like this. So 4x plus 5 by x less than or equal to 0. So this is our real line. Minus 5 by 4, somewhere here 0. So the graph will be like this. So less than or equal to 0 means what? It should be between these two. So x value to lie between minus 5 by 4 and 0 is not allowed because by x is there. You will get like this. Now you should consider the intersection of these two. Right? See, when you consider intersection of these two, what right intersection? This is where your line. Somewhere here minus 1. Minus 5 by 4 will be here. 0 will be here. Right? So this is minus 5 by 4 to 0. Right? What about this? Minus infinity to minus 1 arrow. 0 to infinity. What is common part? This. So x value to lie from minus 5 by 4 to minus 1. So this is your final solution. Yes, understood? You should be very careful about this question. You should have a clear-cut idea about the domain of the inequation first. X plus 1 by x must be greater than 0 means wavy curve. Minus 1, 0, right? So the graph is what like this, because for x greater than 0 all are positive. X belongs to minus infinity to minus 1, union 0 to infinity. Keep like that. Since base is a fraction, inequality will reverse. That point 2 is what? 1 by 5. So bring everything onto one side. You will have like this. Once again wavy curve. 0 minus 5 by 4. You will get like this. X cannot be 0 because it is in the denominator. So less than or equal to 0 means these points. Minus 5 by 4 less than or equal to x, strictly less than 0. Now intersection of these two. Then plot like this. First this is like this. This is what like this. What is the common part of these two? This is the common part. So common part when you write, you get finally x belongs to closed minus 5 by 4 to open minus 1. Okay, right. See, the next problem is log of 2x minus 3 by 4. Log of 2x minus 3 by 4 to base x greater than 2. Log of 2x minus 3 by 4 greater than 2 is our next question. See, first of all, the domain of this means 2x minus 3 by 4 greater than 0. So x is greater than what? 3 by 8. X is greater than 3 by 8. X is greater than 0. X is not equal to 1. So you have to take care of all these points. X is greater than 0. X greater than 3 by 8 is x greater than 3 by 8 anyhow. And x not equal to 1. Right? Now, if you want to remove the log, you should concentrate on the base. Base is a variable. So you should consider two cases. The first case is x value less than 1. And of course greater than 3 by 8. X greater than 3 by 8, x less than 1. If you remove log, inequality will reverse. So 2x minus 3 by 4 less than x square. Right? Take LCM, send it to that side. You will get 4x square minus 8x plus 3 greater than 0 you will get. So 4x square minus 6x minus 2x plus 3 greater than 0. 2x into 2x minus 3 minus 1 into 2x minus 3 like this. So finally 2x minus 1 into 2x minus 3 greater than 0. So x is what? Less than 1 by 2 or x is greater than 3 by 2. Yes, understood? So what is intersection with this? What is intersection with this? X value is from 3 by 2 to 1, x less than 1 by 2. Intersection of these two is what? X value to lie between 3 by 8 to how much? 1 by 2. You will get like this. 3 by 8 is less than 1 by 2. This intersection, this is null set. So A intersection B union C means A intersection B union A intersection C. So A intersection B is this, A intersection C is null set. You got first case like this. Then second case is what? Second case is x greater than 1. This is your second case. Inequality remains same. So 2x minus 3 by 4 greater than x square. So you will get 4x square minus 8x plus 3 less than 0 you get. Greater than 0, they are less than 0. Then if you solve like this, you are going to get x value to lie between what? X value to lie between 1 by 2 to 3 by 2. Yes, x value should lie between the roots. What is intersection with this? X value to lie between 1 to 3 by 2. 1 to 3 by 2. Your final solution is what? This or this. Means union. So the union of these two will be x belongs to open interval 3 by 8 to 1 by 2. Union open interval 1 to 3 by 2. This is your final result. Listen carefully what I did. When the question is given like this, your first duty is write domain. This should be greater than 0. This should be greater than 0. Not equal to 1. So you will get all these things. X greater than 3 by 8. Right? First case is 3 by 8 to 1. If you remove log, inequality will reverse. This routine solving, you can easily solve this. Then when you take intersection with this, you got like this. X greater than 1, inequality remains same. Then solve the quadratic inequality, you will get x value to lie from 1 to 3 by 2. Intersection of this, if you consider, you will get this. Your final answer is what? Case 1 union case 2. Case 1 union case 2. This is how you are supposed to think on this. The next question is 1 plus log of x square plus 1 to base 5 is equal to log of ax square plus 4x plus a for all x belonging to R. Then what are your values? What are your a values? See, this is true for all x belonging to R. So listen, when you talk about domain of this, x square plus 1 greater than 0 for all x belonging to R, no problem. Here base is of course 5. Here ax square plus 4x plus a also must be greater than 0 for all x belonging to R, then only log will exist. For this to happen, a should be positive, delta should be negative. Delta is what? 16 minus 4a square is less than 0. So you are going to get what? A square minus 4 greater than 0, a less than minus 2 or a greater than 2 you get. You keep like this. Now 1 can be written as log 5 to base 5. So the LHS will become what? LHS will become log of log 5 to base 5 plus this. Means log 5x square plus 5 to base 5 is equal to log of ax square plus 4x plus a to base 5. So base 5, no problem, equal to sign is there. So 5x square plus 5 is equal to ax square plus 4x plus a. Right? Now finally x square into 5 minus a minus 4x, right, plus 5 minus a is equal to 0. You will get like this, right? X square into 5 minus a minus 4x plus 5 minus a 0. We can solve this. So if you solve this, what will get? X is equal to 4 plus or minus square root of 16 minus 4 into 5 minus a whole square by 2 into. So what is asking in fact? The question. What is asking in the question? Let me see. Unnecessary solving. He is asking what? Only a values, is it not? He wants the values he wants. See, log x square plus 1. This is, oh sorry. Very sorry. ఇది greater than or equal to it. Please correct this. Greater than or equal to 0, greater than or equal to that form. I'm sorry. This should be greater than or equal to. Sorry. Please correct this. So the problem is 1 plus log of this greater than or equal to this for all x belonging to R. Please correct this. And this is greater than or equal to sign. Then this is okay. Domain you write the domain like this. Up to this, no problem. Now here base is what? More than 1. If you remove log, what I said, inequality remains same. So 5x square plus 5 greater than or equal to ax square plus 4x plus a you will get. True for all x belonging to R. So x square into 5 minus a minus 4x plus 5 minus a greater than or equal to 0 for all x belonging to R. Quadratic expression greater than or equal to 0 means x square coefficient is positive, delta is negative. So 5 minus a greater than 0. Delta less than or equal to 0. 16 minus 4 into 5 minus a whole square like this. 4 fours. Then what you are going to get if we expand this, okay, don't expand. We can write a minus 5 whole square, no problem. A minus 5 whole square greater than or equal to 4. So a minus 5 less than or equal to minus 2 or a minus 5 greater than or equal to 2. What is a minus 5 here less than 0? What's this? This and this. Is it not? This should be positive, means like this. What is intersection of these two? This should happen. This will not happen. So a is less than or equal to what? 3. So this will give you, this is ruled out because a minus 5 is already what? Less than 0. So from this you got here a less than or equal to 3. What is intersection of this and this? The intersection of these two is a value is from 2 to 3. So this is your final answer. Right? Listen, the problem is quite simple. Here, inequality, please correct that. Then this should be positive, means x belongs to R. This should be positive in order to see that log will exist for all x, means a should be positive and delta should be negative because strictly greater than 0. Then you got a value is less than minus 2, a greater than 2. You know how to solve this inequality. Keep like this. Then 1 is log 5 to base 5. You can write like this. Since base is more than 1, safely remove the log. You will get like this. You will get one quadratic inequality in x greater than or equal to 0. For all x belonging to R means x square coefficient is positive, delta is less than or equal to 0. Solve this. You will get a less than or equal to 3. A here 5 minus a positive means a minus 5 negative. Intersection of these two is what? A minus 5 less than minus 2. A less than or equal to 3. So finally a belongs to open interval 2 to